So you can
advocate and we heed this inconvenient truth because we need to be anything but lenient with the future of our youth. And while this is a training and sustaining the future of our planet, there is no rehearsal. The time is now, because the reversal of harm and protection of a future so universal should be anything but controversial. So, Earth, pale blue dots, we will fail you not, just as we chose to go to the moon. We know it's never too soon to choose hope. We choose to do more than cope with climate change. We choose to end it. We refuse to lose. We do this and more, not because it's very easy or nice, but because it is necessary. Because with every dawn, we carry the weight of the fates of this celestial body orbiting a star. And as heavy as the weight sounded, it doesn't hold us down, but it keeps us grounded, steady, ready, because an environmental movement of this size is simply another form of an earthrise. To see it, close your eyes, visualize that all of us in this room and outside of these walls or in these halls, all of us change makers, or in a spacecraft floating like a silver raft in space, and we see the face of a planet anew. We relish the view, we witness its round green and brilliant blue, which inspires us to ask deeply, wholly, what can we do? Open your eyes, know the future of this wise planet is right in sight, right in all of us. Trust this earth uprising, all of us bring light to exciting solutions never tried before, for it is our hope that implores us at our uncompromising core to keep rising up for an earth more than worth fighting for.
All right, well, greetings everyone. I apologize for the sound issues, but we will link that video to the NASA Hunt CTE Month video challenge site so that you can view it afterwards. It's a wonderful video. It was a great recommendation, Dr. Gold. So let me check the chat, make sure there are no other questions I need to address before we begin. All right, well, welcome everyone and greetings. My name is Julia O'Brien. I'm the Senior Director of Communications here at ACTE. And then we are also joined by our co-host, Dr. Florence Gold, who is the NASA Hunt Implementation Project Manager and who you all know well. Again, we are your co-hosts today for today's Student Video Challenge webinar to give you some ideas and insights on how space exploration can provide some solutions to climate change here on Earth. We are joined today by our keynote presenter, who is Dr. Catherine Williamson. She is professor at West Virginia University, and she has her PhD in physics and is passionate about climate change. Catherine is the co-founder of West Virginia Climate Action and was just named 2021 Wonder Woman by West Virginia Living Magazine and was recognized by the National Association for Women in Science. We are also joined today by Erin Spalding, who is a senior at the University of Connecticut and a researcher with the university's Eversource Energy Center. Erin's work focuses on the effects of climate change, leveraging the use of NASA products in his research. Erin also participated in NASA Hunt when he was a student at Windsor High School in Connecticut, so he might have some inside knowledge. And finally, we have a recorded interview, which we made on Monday with Miriam Nielsen, who is studying compound hydrological extremes as a PhD student in Earth and Environmental Sciences at Columbia University. She is an environmental media and change maker who talks about science, climate justice, and eco-activism on her YouTube channel that has over 15,000 subscribers. Miriam is also a video journalist and animator in New York City and has produced several science and educational videos for The Verge and CBS News. And I will be sure to post her YouTube link in the chat, and we'll also include the link on the Student Video Challenge webpage as a resource. So without further ado, we will begin with Dr. Catherine Williamson.
So thank you so much for having me. I'm truly honored to be here and participating in helping our students think about how can space exploration solve climate change. So I've started thinking about climate change more as a professional astronomer in recent years, and I've learned a lot about resources that are out there and communication strategies that I'd like to just share with some students. So, we think about our history as a spacefaring species. Space exploration has helped us in many ways with our rocketry, propulsion systems, satellites. We've been able to design creative miniaturization of so many things like food, waste, just so that we could get to space, get to do what we want to do in space. We've also had to develop communication and a global network of working together, coordination. And of course, space exploration, as we look outward, we get a perspective of ourselves. We really learned a lot about Earth as we've looked beyond Earth. So in learning about other worlds, we've learned that a greenhouse effect, like we observe on Venus, can be a really huge driver of a planet's climate. We see a runaway greenhouse effect on Venus. We've learned about an anti-greenhouse effect on Saturn's moon Titan. We've learned about dust storms on Mars, and we've had to try to understand those. We've had to use data from volcanoes on Earth, use data from nuclear test explosions to build into our models of planetary geology, allowing us to discover that that something like a comet or asteroid impact could actually be responsible for the extinction of the dinosaurs, and allowed us to figure out that something like many nuclear bomb explosions could actually plunge us into a nuclear winter. And so we really need to pay attention. So we've learned a lot from these different ways of studying. And sometimes when we're so successful getting to the moon and with all of our satellite programs and eventually, getting people to Mars, we can think that it is easier than it really is. We can fool ourselves into thinking that Mars, as our closest neighbor, is really a lot more like Earth than it really is. We can dream about terraforming Mars to maybe be more like Earth. But Mars doesn't have a lot of the things that Earth has, including a protective magnetic field. So even if we could create an atmosphere on Mars, that atmosphere would likely be swept away by the solar wind. So as exciting as it is to think about living, working on Mars, Mars is not a lifeboat for the human species or for Earthlings in general. There is no planet B, right? We've heard that catchphrase before. This is something that increasingly astronomers like myself are turning our attention towards in communicating the vast knowledge that we have about the universe. And we've learned that we are, sorry about that, my mouse is a little crazy. We've learned that we are really, that Earth is really all we have. So I definitely recommend for our students to check out the Astronomers for Earth website and read about kind of why astronomers are taking this perspective and using this to motivate action. I also want to raise the alarm. As Earthlings, we are at a critical moment. We have climate change, we have global warming, leading to a variety of interconnected issues. It's not just warmer temperatures. Warmer temperatures create a lot of cascading impacts, like stronger storms. We have our oceans becoming more acidic as they try to absorb carbon dioxide. We have environmental refugees, people that can no longer grow and make crops and make a living where they used to, having to pick up and move for their livelihoods. We have sea level rise. We have devastating heat waves out west. We've seen fires. Here in my home state of West Virginia, we've had flooding. We've had water shortages, air quality problems, and all of this can feel very, very scary. And I would never want to end my presentation here because this just makes all of us want to shut down. So how do we not shut down? How do we look at the data that we have, that we do know that this is happening, We have so much data that shows what's happening. We have mud cores, ice cores. A lot of people are fascinated to learn that we can drill 2 miles down into the Arctic and Antarctic and capture little bubbles of the atmosphere from hundreds of thousands of years ago, allowing us to accurately model our current temperature variations and put them in context of Earth's history. We build rockets to study Earth's atmosphere. We have indigenous knowledge providing information about Earth systems. We have tree ring data. We have satellites, weather balloons, temperature stations, and computer modeling, so that when we see something like a forest fire or a flood, we can say statistically, it's unlikely that that should have happened with that severity this frequently. And so we have a lot of confidence that climate change is happening, and we have a lot of resources for learning more. So as students create their videos, you'll want to use resources from reliable sources. Probably the best source that you can find is NASA's climate website, climate.nasa.gov, really easy to remember. And you can explore so much here. There's so much I recommend. There you can see images of change. So these are before and after pictures we can see before and after. You might want to use something like that in your video. You can see NASA's Earth Minute videos, learning about why does NASA study Earth, learning about specific particles like aerosols. How do clouds impact climate change? Because they reflect sunlight, but they also trap heat. So what does that mean? We also have a variety of interactives, and one of my favorites, the Beautiful Earth Gallery. These are just simply beautiful images of Earth that can really inspire your audience if you're making a video to pay attention. And as Astronomers for Planet Earth tells us, awe triggers empathy. So if you can have something beautiful in your presentation, something that inspires that wow moment for people, that you might have a better chance of kind of catching their attention and having them take action. We also have a variety of data visualizations from NASA. So these are found at the Goddard Space Flight Center website. All of these are very current. We can see like the current hurricane season. Maybe you can, maybe you want the video about temperature or sea level rise. Whatever topic you choose to focus on, NASA most likely has a visualization about it. And some of them are quite interesting. There's even videos about air quality and COVID impacts. So there's so much interesting things you can use here. And again, these are data driven. We also have NASA's Eyes on Earth. So we have temperature, air quality, fire, water data from a variety of live NASA satellites. We call them, they're like NASA's Eyes on Earth, right? So we're looking inward with our satellites as well as outward to the universe. So this is also a great resource for people looking to learn about climate change. And the fact is that while we have all of these resources, we seem to not be able to communicate them very well, which is why we need your help. We need people who are experts in communication to convey all of the data we've just seen in a relatable way to people so that they inspire action, because we have what's called a consensus gap. In reality, 97% of climate scientists agree global warming is happening and it's human caused. But the public thinks that only 55% of climate scientists agree. So that's not true. And we want to communicate, no, scientists agree. Even if the public debates this issue, it's not a scientific debate. So how do we know these stats? Where do these stats come from? As always, we want to be data driven. So it's important to look at where does this data come from? We have NASA's stats that 97% of scientists agree. And this is from a variety of reports, which you can read from this website and perhaps link in your video as well. As you work on what the public thinks, remember you'll be speaking to people in the public and in your area and across the nation. You want to know what people are thinking. And this is where the Yale climate opinion maps come in handy. I love these maps. So this is, what do people think? And so you can find mismatches between what scientists say and what the public says, and potentially target that as a good messaging strategy for yourself. You can use their drop-down menu to see how many people think global warming is happening, if people are worried about global warming, if they think that it will harm plants and animals, and if we should fund research into renewable energy, and if schools should be teaching about global warming. So there's a variety of statistics that you can click on and check. And for instance, this one, we see that 78% of people in the United States think schools should be teaching about global warming. So perhaps you're already engaged in this by participating in this challenge in the first place. And communication requires a lot of creativity. So here are 4 different ways of looking at the same data. The data is temperature anomaly, meaning how is the temperature different than how it usually is, right? And so we've got a graph, right, which NASA scientists might look at and might want to choose to look at, but a graph like this might be off-putting to your audience. So we have another way of seeing it, color coding, where blue represents cooler colors and red represents warmer colors. That might be good for some audiences that are very visual, maybe not good for people who have visual impairments. We also have another visual, a map of the world over the past 150 years or so, looking at the temperature variations over time, ultimately seeing that the present day is much warmer than the average. And we even have this very creative cello playing the same data.
Scott St. George. And
so, sorry guys, we want to hear his cello. He plays low notes for low temperatures in the 1900s. And as the song goes on, the notes get higher. To show the increasing temperature. So here's a great way to communicate the same data with sound. So we have visual, we have sound. What are the pros and cons of these different ways of communicating? And which way would you choose for your video if you were going to focus on temperature? So you want to think creatively about how can you communicate something in a way that's going to get people interested. One thing you really want to do is focus on solutions too. There's if you don't talk about solutions, sometimes we can feel like it's not like we are losing hope. So the Project Drawdown website has a variety of solutions that you can explore. You can see they've got dozens and dozens of different solutions. Maybe you pick one that you want that seems relevant to your audience: composting, wetland restoration, carpooling, right? The reality is that any solution that we're going to have is going to be a variety of solutions. So we should be thinking about all of these and pick what feels relevant to your messaging. So we also have the En-ROADS Climate Solutions modeler. This is the most accurate modeler for how we handle renewables and and deforestation, electrification, and a variety of other factors, and how that impacts temperature. So you could use that for your video as well to get the most accurate data. And finally, you want to think about inspiring collective action. A lot of times when we just say recycle more or carpool more, that's true, but what we're really going to need is people working together. So look up environmental or climate action groups in your area and help people get connected to those. Help people figure out how to communicate with each other so that we can all be working together and have larger impact when we work together. And the fact that you're here working on this challenge, you're already helping the situation. Because as Katherine Hayhoe says, climate scientist, she says, the most important thing you can do to fight climate change is to talk about it. And that's what you're doing with this video challenge. You're talking about it. So you're already helping. So good luck. And please reach out if you have any questions. I can't wait to see what you guys create. So thank you so much for having me.
Thank you so much, Dr. Williamson. That was a wonderful presentation. Lots of data-driven research and inspiration for the students, and just great visual and audio resources for the students. Thank you very much for that. All right, we will turn the podium over now to Mr. Erin Spalding.
So hello, everyone. I'm Erin Spalding. You can call me Erin. And I'm super excited to talk a little bit about what I've been working on and how space exploration can be used to help understand climate change. You probably want to know a little bit about me, so I'll give a quick background and then jump into it. And I'm not sure how questions work, but feel free to raise your hand or put something in chat, and I'll try to answer things as I go if anything comes up. So as you mentioned, I'm an undergraduate at the University of Connecticut. I'm actually studying math and electrical engineering here. But before UConn, I was actually a Hunch participant. And so the picture on the left shows a picture of a tape dispenser project that I worked on that actually flew to space on a SpaceX rocket last year. But for the past year and a half, I've been working on something a little bit different. I've actually been doing research in the Eversource Energy Center. So I'm not sure if you know what Eversource is. You would have to be in New England for that. But Eversource is actually New England's largest energy provider. And so what that means is that if you live in New England, you probably buy your electricity from Eversource. But that also means Eversource is responsible for millions and millions of miles of electric cables and for thousands and thousands of customers across Connecticut, Massachusetts, New Hampshire. And so if you know anything about New England, you know that we really have all 4 seasons. So we get heat waves in summer, we get hurricanes and tornadoes in the fall, and we get snow and ice storms in winter and spring. And so what we do in our lab is we maintain a power outage model to help predict the effects of weather on outages before severe weather comes. But my time in the lab has been focusing on extreme events, tuning existing models, and building models for tree failure. On the right, I have a photo showing damages following Storm Vaya in northern Italy. Storm Vaya was an extreme event. So what that means is a once or twice in a century event that moved across parts of northern Italy and southern Europe. However, this is really special since it caused enormous damage to trees and very high rates of tree failure. And so you can see some of the impacts in this photo. This is a photo of a suburban area. But if you actually Google photos of Vaya, that's V-A-I-A, you'll actually see forests where every tree is just on the ground. And so this is really bad for the environment. This is really bad for people living there. And this is really bad for forests in the long run. But one question you probably have is why? Why do we build models? And does models actually help anyone? And I could just say that models help us save money, and models are fun to build and they help us publish things. But really models do a lot more. I should probably explain what I mean when I say model. When I say model, I just mean like a mathematical relationship that connects data. So like one example could be more rain means more outages. And that's a really, really simple model, but it's still a model that could be right. In our case, we use something called machine learning, and that lets us deal with very, very large data sets and build very, very large models. But it lets us do it in a very complex, very mathematical way that lets us interpret these results. And if you go through your daily life, you definitely use models all the time. So when you wake up, you check the weather, or you get directions, or run a Google search, you're actually using models that someone else built. But this takes us back to our question of why we do this in the first place. And we do it really for 2 reasons. We do it because models can actually tell us the future, and because models can help us understand the world around us. They help us understand it in very complex but very mathematical ways. And so it lets us build models for things like tree failure, but then use insights from these to help manage future forests or shape how we structure neighborhoods or build our future environment. But of course, how does this relate to space exploration? So it turns out that space exploration actually improves the data that we have about Earth. And so on the left, you can see we use data sets to build our models, and then we use that to create predictions. And so the more we improve our data, the more we improve our models. And the more we improve our models, the more we improve our complex understanding of complex systems. And that also means predictions improve. So I'll talk about a couple of data sets that our lab uses and that I've used in the past to help model these complex things. The first example is NASA MODIS. This stands for the Moderate Resolution Imaging Spectroradiometer. But basically, this just tells us land cover details. So things like what types of tree or what types of what is on the surface. So is it a neighborhood? Is it a city? Or is it shrubbery? Or is it very tall trees? Or is it coniferous forests? But it turns out these details tend to be super, super important when looking at things like tree failure. And of course, that isn't really surprising. That shouldn't really surprise anybody if you can't have tree failure without trees. But what it does teach us is about different tree stands in forestry. One thing we actually noticed this summer when I was building a model was that coniferous trees in northern Italy tended to have very high rates of failure. And it turns out that stands of trees composed mostly of coniferous trees tended to be more susceptible to high rates of tree failure. And that's just one example of things we learned about forests when building models that we might not have noticed without these models. Another data set that we've been using has been the Copernicus data set. This data set is actually supported by the EU, not NASA, and is maintained by the Sentinels system. These track things like ocean levels and atmospheric properties. They also include land cover data sets like MODIS. On the right is a plot of the evergreen forest areas across that northern Italy portion. But I think this is really, really cool since that means mechanical engineers working at NASA or electrical engineers working in the EU are helping to improve these models and helping to improve our understanding of Earth just by providing more reliable, more accurate data about our own planet. And I think that's pretty cool. But if we go back to our diagram from before, and we add data sources such as weather or land cover or topographical information, we see that improving data sources improves our model. But of course, we want to connect this back to climate change. And we want to know why we build these models to tackle and understand how our world works. And if we can go back to the original two statements, and that's that models can tell us the future, and models help us understand the world around us. And turns out that is really powerful when trying to shape how we build the world around us, but then also how we react to how the world's changing. But yeah. And are there any questions?
All right, I'm checking the chat just to make sure. I don't see any questions, but if we receive any follow-up questions post-event, could we forward them to you, Erin?
That would be great. And anyone can reach out to me at any time.
All right. Thank you so much, Erin. That was a wonderful presentation, and I hopefully will inspire some students to create their own models for space exploration and how that can solve climate change. Thank you.
Okay, awesome.
All right. On Monday, NASA Hunch recorded an interview with Miriam Nielsen. It's about 12 minutes. So I'm going to run that now. She, again, is a student at Columbia. And so I'm going to start that here in just a minute.
All right. Good morning, everyone. We are here with Miriam Nelson, Julia O'Brien, and Catherine Williamson, all who are going to be participating in the webinar. Today would be on Wednesday, but this is Monday right now. Miriam can't make it live, so we have her answering some questions that students in the Hunch program have developed. And the first question, because Miriam has a very interesting background, is about being a video journalist. Miriam, would you like to tell us a little bit about that?
Totally. When I was in college, I studied environmental science and film, mostly because I couldn't pick. Those were the two big interests going into college, and I just kind of stuck with them the whole time. But then when I graduated, it was actually quite a bit easier to get a job working in media. So I moved to New York City and started working for a big news organization, helping make their morning news show. But I still kind of had that environmental interest. So I slowly moved from just doing news into much more kind of information journalism, telling people stories about the environment, reporting on what scientists were doing. And I really found that very fulfilling for a really long time.
Awesome. Thank you so much. And you have a YouTube channel. You want to tell us a little bit about that YouTube channel that you have?
Sure. So I actually have been part of quite a few YouTube channels. One of them was with PBS Digital Studios. It's called Hot Mess. It's kind of a fun, really animated, literally animated, a lot of it is animated show about climate change and the environment. We talk about everything from what's going on with hurricanes and cyclones to whether or not individual actions matter in responding to the climate crisis, to how important it is to build community to respond to a disaster. And I also have a personal channel where I kind of talk about my own feelings and how I respond to climate change, the kind of activism that I do, and any science that interests me.
Thank you. I thought one of the most interesting parts of your YouTube presence is the video which has music with you sitting there reading a book.
Oh, yes. Yeah, I did a couple of, there's a theme of doing kind of, chill music to listen and study to, but I did one that was a fundraiser for a local environmental justice work that I'm a member of. And I partnered with a couple musicians to have some relaxing music that you can put on while you're studying. And the ad revenue that YouTube generates, I donate it to the organization We Act for Environmental Justice.
Wow, it looked like a lot of effort went into that one too, because it was a cartoon. Everyone should get to look at that too. You can
very fun to make.
Yeah, you can Google her YouTube presence, and we're going to jump into some questions now. And the first question is, how does global warming affect all the animals, including humans on Earth?
Yeah, so that's a super big question. A lot of ways. Basically, every possible way you can imagine, because if you think about it, animals and humans live on the Earth. The climate is changing. Basically, influences basically everything in their ecosystems, ours and animals. Global warming, the name's kind of in the title. The temperatures are increasing. That's going to impact people and animals. A lot of species only live in certain temperature ranges, and so when they go above that, their systems aren't. They did not evolve to live in those kind of temperatures. The other thing that's kind of relevant to what I actually research is kind of extremes of precipitation and drought that are happening as this get more and more scary.
Great answer. Thank you. Yeah. That's a great answer. Anyone have any other contributions there?
Amen.
Sure.
Yeah, I think maybe people have also heard that, we're in this mass extinction of Earth. So, it's individual animals suffering, species going extinct more frequently. And actually, like in the news, we're seeing it. I just saw a couple of weeks ago, another species went extinct. And so that we're losing like our biodiversity. And so not only is it sad for those animals, it's threatening to kind of all life on Earth, that we don't have the interconnections that we rely on in many ways that we don't even realize we rely on. So I think I would just add that.
Oh, thank you so much. That's awesome. Okay, next question. Which gases cause global warming besides carbon dioxide?
So most obviously you've probably heard a lot about carbon dioxide. So carbon dioxide and water vapor are the two big gases up in the atmosphere that are doing most of the warming that we see. But the other big hitters would be methane and nitrous oxide, as well as a smaller percentage, but still very important. We've got whole international agreements about it. Fluorinated gases are the last big group.
Wow. Okay, that's important information because all we hear all the time is about carbon dioxide. What is causing climate change the most? Is that the carbon dioxide levels going up?
Yeah, I mean, I would say climate change is being caused the most by us burning fossil fuels and releasing carbon dioxide. That is like far and away the biggest cause.
Here's this question actually came from the teacher, and he said, which industry in the United States is affecting climate change the most, and what can we do about it?
Well, if you listen to the comments on my YouTube channel, they'll say it's the meat industry, the agricultural industry, which is a huge player. But I would say that a more interesting answer is it really depends on where you are in the US. So where I live in New York City, buildings are the biggest emitter by far, like beats transportation, there's not a lot of agriculture going on in New York City, obviously, but beats every other source of emissions. It's all buildings. And so reducing emissions is really local and specific, I think. And so thinking about where you are and where you live and what's causing the biggest emissions there is super important. Across the whole US, I think the biggest chunks are, in this order, is electricity generation, which is primarily still from fossil fuels. Industry, which includes like powering industrial buildings and concrete production, and then transportation. So cars and also all the trucks that bring all of our stuff all over the country.
Oh, thank you for that answer. And what can each individual do to help solve the climate crisis?
Yeah, that's the $1 million question, right? I have a couple different ways that I like to answer this, but I think kind of the way that I normally go with is that I think the best thing that anyone can do is make change in the spaces that they are. So you're a student in a high school. Well, it'd be great if you make sure your house turns off their lights all the time, or you do all the kind of things that there's been PSAs for decades about. That's great. But a more powerful thing is to figure out how your school could transition away from fossil fuels or reduce food waste in a significant amount, basically lower the emissions of your entire school rather than just focusing on what you as a single person can do. And that's a lot harder, obviously, but it means like building a coalition between your classmates and their parents and maybe the school board, and kind of petitioning the folks that actually run and control the switches at the school to make changes to actually get something done. But that's going to magnify your impact way more than just beyond your own personal carbon footprint, so to say. And kind of the same thing if you really care about food waste and the emissions from that and the trash from that, this is actually, I've seen a lot of schools do this really successfully, is kind of petition to get your cafeteria to start composting. It's a really easy way to reduce the emissions of your school, also contribute to your local environment, and only takes a little bit of campaigning, I would say. And I guess the other thing to remember is that even if you aren't old enough to vote, you can still get involved in local politics and pressure the people who represent you and your family to think about climate and how they're governing your space. You are represented by them even if you can't vote for them yet. And you can always remind them that you will be able to vote shortly if you can't yet.
That's awesome. Thank you. Well, we're down to the last question, and that is, Spencer, did you have a question about that?
What would be the most effective way to do that? Like, how would you get around to doing that, fixing some of the ways that goes around, I guess?
Yeah. I mean, in my experience, it's a lot of talking to people. So if you think about, here's the thing I want to change. So I'll take composting because I think that's like the easiest route. So if you know that your school does food waste, but doesn't handle its food waste in any way other than just throwing it into the garbage and getting it picked up later on, you could, for starters, look up if there is composting, municipal scale composting in your area. And you could call them and say, hey, do you offer this program in schools? And maybe they'll be like, yeah. And you're like, you should call my school. Here's the administrative number. And they'll just start hassling them because they want the business. So like, that's one way to go. And like use capitalism for gain. The other option is to talk to the folks who are working in the cafeteria, see if they have any interest, because you also have to remember that like this is an additional job that they have to have on top of the other work they're already doing. So talk to them, get them interested and excited. And it's probably easier if there's like my high school had a kind of like environment earth club. And like when I was in high school, we were still trying to get the high school to just recycle paper, which fortunately most high schools do now. We can talk about the efficacy of recycling if we want, but that's where we were at, was trying to get paper recycled. And so we did a lot of talking to like the janitorial staff, and then eventually we were talking to the president of the school. The more people you have who can send emails and make phone calls and just kind of hassle people until stuff gets done, because most of these things places are doing. And so you can find a model that your school could copy.
That's a good idea.
That's the kind of let the work that's already been done just repeat it where you are.
That's a great idea. Thank you for that answer, and thanks for that important question. All right, the last question. What is the best renewable energy to use to replace our natural resources that, of course, take thousands of years to revive when they're gone?
Yeah, I mean, I'm definitely not an expert on energy production, but I mean, I'm not always a big fan of wind and solar. I think it obviously matters where you are, what's going to be most effective. If you're in the middle of the country where there's huge amounts of wind, that seems like a no-brainer. But what I do like solar in that you can go all the way commercial scale, it's huge, but you can also just put it on a small house. That's another space where like working in a school, like your school has a roof. That's a place there where they could install solar. The nice thing about solar especially is that there's tons of, at least it's state to state and federal kind of rebates. So your school could probably like make back some money switching over eventually, or that's the ideal way. So I'm a big fan of that. I think another one that doesn't get as much airtime is I'm a big fan of ground source heating, or geothermal, which is basically using the power of the kind of few feet below the earth. It's always roughly 50 degrees. And so if you can pump that out, you can keep your home and or school cool or a comfortable temperature all year round, regardless of what's going on outside, for less electricity than plugging in a big air conditioner or actually burning fossil fuels to keep things warm.
Oh, very good. All right. Well, thank you so much, Miriam, for those wonderful answers. And Spencer, thank you and your Punch students in your class for making up the questions.
All right, well, that was wonderful. So at this point in the presentation, we'd like to take any questions you might have about the student video challenge. And first, let me offer that the deadline is April 1st. The video length is 2 minutes or less. We ask that you submit your video using a YouTube link. And we have resources and all the guidance on our ACTE CTE month NASA Hunch webpage, which I will post in the chat here in a minute. I'm just going to turn it over to Dr. Gold to see if she has any additional comments she would like to add.
Well, I can't thank our presenters today, Dr. Williamson and Erin. They did a tremendous job. That is so much information that I think the students who are lucky enough to get to see this webinar will have so much guidance that they will be overloaded with stuff. You both did an incredible job. Thank you so much. And thank you, Julia and the Association for Career and Technical Education, for partnering with us and presenting this also. It will be recorded and be online. So we are here to answer any questions that you may have. And thank you all who joined this webinar today. That was really awesome. Thank you so much. I'm excited about this video challenge, and I love the topic because of all the reasons that our presenters did such an amazing job in presenting. So thank you all.
Thank you for having me. This is great.
Oh, you did an incredible job. I couldn't ask for a better speaker. So thank you. And Erin too, you both did an amazing job.
All right, well, thank you all. I don't see any questions at this point, but again, if you have any questions post-webinar, please don't hesitate to either ask me or Dr. Gold, and we'll be happy to address your questions. Thank you again. As Dr. Gold said, we'll have this video posted shortly after this webinar, and we hope you all have a great rest of your day.
Thank you all so much. Bye-bye.
Bye.
Thank you.
Bye-bye. Thank you.